Left, Right, in the Middle is made possible through grant funding by SRCI, the Student Research and Creativity Institute at Saginaw Valley State University. SRCI, your dream, your project, your research.
Global warming is already affecting people. The Texas, Oklahoma, Mexico heat wave and drought last year, Moscow the year before, and Europe in 2003 were all exceptional events, more than 3 standard deviations outside the norm. 50 years ago, such anomalies covered only 2 to 3/10% of the land area. In recent years, because of global warming, they now cover about 10%, an increase by a factor of 25 to 50. So we can say with a high degree of confidence that the severe Texas and Moscow heat waves were not natural, they were caused by global warming. An important impact, if global warming continues, will be on the breadbasket of our nation and the world, the Midwest and Great Plains, which are expected to become prone to extreme droughts, worse than the Dust Bowl, within just a few decades, if we let global warming continue.
We can't attribute any particular weather event to climate change. What we do know is the temperature around the globe is increasing faster than was predicted even 10 years ago. We do know that the Arctic ice cap is melting faster than was predicted even 5 years ago. I am a firm believer that climate change is real, that it is impacted by human behavior and carbon emissions. And as a consequence, I think we've got an obligation to future generations to do something about it. Understandably, I think the American people right now have been so focused and will continue to be focused on our economy and jobs and growth that, if the message is somehow we're going to ignore jobs and growth simply to address climate change, I don't think anybody's going to go for that. I won't go for that. If, on the other hand, we can shape an agenda that says we can create jobs, advance growth, and make a serious dent in climate change and be an international leader, I think that's something that the American people would support.
Not here to apologize. Don't give me that look in your eyes. There's nothing worse than a man who thinks he knows. I'll tell you the honest truth. I'm not scared to, like in my youth. Now that we both know exactly what we chose. Oh, this is hard love. Oh, this is hard love. We don't mean to be as mean as we all are.
Welcome to Left, Right, in the Middle. I'm your host, Scott. Well, I hope everyone had a great holiday week. In that opening audio, you heard James Hansen, former NASA scientist, and considered by most one of the leading experts in global climate change, commenting about global climate change at a TED Talk conference. And then you heard President Obama responding to a question about how the U.S. would address climate change going forward following the UN Climate Change Conference in Doha, Qatar, which took place just a few weeks after he was elected to his second term in office. And speaking of that election, this was the first election since 1988 in which climate change wasn't discussed at least once during one of the presidential debates. 1988 was also the year that James Hansen first briefed Congress on the dangers of global climate change due to man-made emissions. So if you haven't guessed, this show I will be discussing global climate change. But I'm not going to be discussing it in the sense of exploring whether it's happening or not, because I believe the consensus is in. And it's happening, people. Moreover, I think it should be considered one of the leading issues in not only American politics, but in world politics. As you will hopefully see in this show, global climate change has implications beyond the environment. It also affects our health, the economy, and our national security, which makes the fact that there was no mention of global climate change during the debates all that more deplorable. Now, I typically strive to be as balanced as I can when discussing issues on this show, but this is one issue that I will not entertain the naysayers. I think there can be some debate as to how severe some of the outcomes of global climate change will be, things such as the amount of ice melt and sea rise, the amount of drought and famine, and the amount of species extinctions, things along those lines. However, I don't think you can make the argument that it isn't happening and that it isn't largely due to man-made emissions. So in this show, I'm going to discuss some of the expected outcomes of global climate change, how the media is or isn't covering the issue, why there still exists denial that it is indeed happening, and ways that we can hopefully right the ship. I don't expect that I can convince anyone who doesn't believe global climate change is happening to believe otherwise, for I think those people are entrenched in their beliefs, which are based more on ideology than on what the science and physical evidence can show them. But what I am hoping is that I can convince believers that global climate change should be considered one of the most important issues of this generation. So I hope you'll stay tuned to this episode of Left, Right, in the Middle, and please feel free to post your thoughts concerning this show or any other political topic to the Facebook page, which can be linked to directly from the show's website, lrtmpodcast.com. As I stated in the opening, I'm not interested in exploring whether global climate change is happening, because I believe the evidence is pretty definitive. And to support that claim, I offer a report issued by the Department of Defense in October 2011, titled Trends and Implications of Climate Change for National and International Security. As always, a link to this report is available at the show's website, but I'd like to highlight just a few things from this report. And first, from the executive summary, it tells us, this report describes evidence of impacts over recent decades while recognizing uncertainty about the pace of future changes. It discusses the shortfalls in climate information, climate science, and climate models, and the resultant scope of the uncertainties in projections. At the same time, it provides compelling evidence that climate impacts are observable, measurable, real, and have both near and long-term consequences. It recognizes that changes already underway are having and will continue to have major consequences for the political, economic, and geographic world as we know it. And further on it says, to the extent that greenhouse gases are causing land and sea surface warming, the long life of some greenhouse gases in the atmosphere means that effects will continue to increase and will be long-lasting even with no further addition to the concentration of greenhouse gases. Hence, this is a challenge that cannot be solved. Instead, it must be managed for the long term. This report addresses the need and prospects for approaches to address the near-term impact on human population and longer-term adaptation to climate change. The impact on human populations, near and long-term, translates to impact on national and international security. And it goes on to say, the effects can be further exacerbated by the nature of the human response or the lack of response. So here it's basically saying, we have a huge problem, we know it's a problem, we can see the measurable effects of the problem, but there's uncertainty as to the projections of how severe this problem can possibly be. But again, this is saying there is a problem. Then in the next section, which is titled Climate Observation, Modeling, and Projection Needs, it says this report uses data and projections from a wide variety of sources to discuss trends and consequences. While this data comes from credible sources, climate information systems and climate model infidelity leave room for wide variances in projections. Decision-making support demands a responsive, comprehensive, and informative climate information system. The system will need to include extensive, credible reporting and better science to predict the long-term implications of impacts and demand for adaptability. Progress towards producing such a system will require a systematic effort to define requirements, architecture, and implementation plans. Currently, no coherent integrated climate information system capable of generating reliable, sustained, and actionable client data and projections exists. Today's climate observations and models exist only as a loose federation of programs at many government agencies, academia, industry, and non-governmental organizations. But in a little bit, I'm going to get back to James Hansen. And I think, while I agree somewhat with what this is saying, that we don't have a comprehensive system that we can use to track or to try to make reliable projections, I think if we look at what James Hansen told us back in the 1980s and what his projections were, they fall pretty well in line with what's going on right now. So to say that we don't have a reliable system of reliable projections, I think is kind of ignoring the fact that James Hansen was pretty prescient back in the 1980s concerning what we should expect from our climate, not only now, but if you look at his models going forward. And then I'll also get into a few things later on concerning, some things that have been a little bit off, but it tends to be if they're off, say things such as sea level rise, ice melt, things like that, they tend to be off, erring on the side of saying we thought it was going to be this bad, but it's actually worse. This report by the DoD goes on to talk about things such as trends and the consequences, the role of national security, and what the different departments need to do as far as recommendations for what needs to be done. I'm not going to go through all of this. Like I said, this is available on the website if you want to go through and look at it. What I do want to do is touch on a section titled Current Climate Change Situation and Trends. Now, the first thing it talks about is surface temperature increasing. And it says between 1906 and 2005, the global average surface air temperature increased by approximately 0.74 degrees Celsius. Between 1906 and 2005, the global average surface air temperature increased by approximately 0.74 degrees. The warming trend increased toward the end of this period from 1979 to 2005 to a rate of 0.17 degrees Celsius. NOAA's most recent analysis of global surface temperature change states, global temperature is rising as fast in the past decade as in the prior 2 decades, despite year-to-year fluctuations associated with El Niño-La Niña cycle of tropical ocean temperatures. Record high global 12-month running mean temperature for the period with instrumental data was reached in 2010. The current estimate of continued temperature increase is 0.2 degrees Celsius per decade. We may be entering a multi-decade period of low solar activity that could give rise to a cooling effect of around 0.2 degrees Celsius over the next 2 to 3 decades. At the same time, atmospheric aerosols that have been estimated to reduce warming by 1.1 degrees Celsius have been decreasing since the 1990s, slowly increasing the amount of sunlight reaching Earth's surface. So, we had this push back in the 70s to eliminate these aerosols being put into the environment, which were actually blocking sunlight from coming in. So now these are starting to deplete, allowing more sunlight in, plus we have the carbon capture that's going on. And what's really interesting here is that we are in a period of low solar activity, meaning that the sun isn't actually as hot as it normally is. The sun goes through cycles itself. Sometimes there is higher amounts of solar radiation coming off of it than other times, and right now we are in a low solar activity period. And now think about that. We're in a low solar activity period right now, and yet the Earth is still warming. Now, if we're in a period of high solar activity, can you imagine how much more we would be warming? During a time when we should actually probably be going through a cooling effect because of the fact that we're in low solar activity, we are actually warming up. I think that is just more evidence that global climate change is happening, global warming is happening. And of course, the argument can be made, well, why is it happening? Well, it's not due to natural activity if the sun is in a period of low solar activity. In the next section, titled Ocean Temperature is Increasing, it says the ocean temperature has a major impact on marine ecosystems, and the associated thermal expansion plays a role in global sea level rise. Increases in sea surface temperature, or SST, have been linked to increases in storm activity in the Atlantic. Warming of the Indian Ocean appears to have been a significant factor in the increase of drought in East Africa. A southward shift of the warmest SST in the Atlantic has likely contributed to drought in West Africa. So Africa is getting hit by both sides here. The heat content in the upper 700 meters of the ocean increased over the period 1969 to 2003 by more than 50%. The heat content then reached a plateau in the year 2004 to 2008. The North Sea and the Baltic Sea, in particular, have experienced an unprecedented warming trend since the mid-1980s in all seasons. Temperatures in summer since 1985 have increased at nearly triple the global warming rate and 2 to 5 times faster than those in other seasons. In the southern hemisphere, each 1 degree rise in global average temperatures boosted Indian Ocean SSTs by about 1.5 degrees Celsius during the past few decades. The next section, titled Greenland and Antarctic Ice Sheets Losing Mass, says observational data indicated that melting land ice contributes significantly more to sea level rise than thermal expansion of the oceans. Over the last 5 years, for example, land ice was responsible for 80% of the observed sea level rise over the past 5 years. Gravitational measures from the Gravity Recovery and Climate Experiment satellites indicate that the Greenland ice sheet is losing mass at an accelerated rate. During the most recent 11 summers, melting has been greater than the average of the available time series, 1973 to 2007. Melting in the summer of 2007 established a new record which was 60% above the previous high in 1998. The next section is titled Glaciers and Snow Cover Decreasing. The average annual melting rate of mountain glaciers has doubled since 2000 compared to the already accelerated melting rates observed in the 2 decades before. The year 2006 established a new record for annual mass loss of the reference glaciers under long-term observations. And what's significant here is a lot of high-density population areas, areas, say, in India and China, where a good portion of the world's population lives, depends on water coming down through rivers from this glacier melt-off. Now, once these glaciers are gone, where are they going to get their water from? And I think that's a real significant point here, and I think something that people don't really consider. We always talk about energy and oil and things along that line, and global conflict arising from that. And I don't think enough focus has been put on the global conflict that's going to be caused when the water runs out. So the next section is titled Arctic Ice Sea Extent Decreasing, Thinning Increasing. And it says recent studies predict that the Arctic will be free of summer ice sometime between 2030 and 2080, earlier than previously anticipated. Now, you may say this doesn't really seem to have that dire of consequences. I mean, what's significant about not having ice in the Arctic Ocean? It actually opens shipping lanes and can be beneficial. And in a way it can, yes. But we're looking at destroying an ecosystem here. That ice sheet is itself an ecosystem, whether it's the life that lives in the ocean under it or the life that lives on top of it. And if we destroy an entire ecosystem, there's the butterfly effect. It's going to reverberate throughout the entire food chain. Where it's going to land, we don't know. But all I know is it can't be good. Now, the next section is titled More Frequent and Longer Droughts, and in here it says, the percentage of global land surface in drought has increased by 3.4% per decade in the period 1952 to 1998. In terms of the Palmer Drought Severity Index, areas in severe and extreme drought have more than doubled since the 1970s, with a large jump in the early 1980s due to an El Niño Southern Oscillation-induced precipitation decrease and a subsequent expansion primarily due to surface warming. And the next section is titled Extreme Temperatures More Common. And this says, elevated temperatures have both direct and indirect impacts on many important biological systems. Those most commonly discussed are impacts on human health and agricultural growing seasons. Since 1950, elevated temperatures have increased by between 1 degree Celsius and 3 degrees Celsius, significantly more than the change in average temperature. Other recent research combines observation and modeling data to suggest a high probability, and it says greater than 90%, that growing season temperatures in the tropics and subtropics by the end of the 21st century will exceed the most extreme seasonal temperatures recorded from 1900 to 2006. In temperate regions, the hottest seasons on record will represent the future norm in many locations. The next section is titled Tropical Cyclone Intensity Increasing. It says the consequences of increased cyclone intensity are potentially severe, particularly when coupled with sea level rise, and could affect coastal communities around the world. The destructive power of tropical cyclones, which are storms, hurricanes, and typhoons, has increased since 1970, owing to increase in intensity and duration, and as much as 70% in the Atlantic and Pacific. The next section is titled Mid-Latitude Wind Patterns and Storm Tracks Shifting Poleward. And this says that there is a wide agreement on a poleward shift in storm tracks, and such change leads to changes in regions affected by storm-related strong winds and heavy precipitation, as well as high waves and storm surges. Now, I think we just had a huge storm along the East Coast that particularly affected New York City that supports this. The next section is Sea level is rising. It says, increased understanding of feedback cycles and glacier dynamics has resulted in dramatic increases in projections of future sea level rise, compared to that given in previous studies. It is increasingly probable that global sea level rise will exceed 1 meter by 2100. And a meter is pretty comparable to a yard. Now, in a little summation here that says findings on climate trends, it says, observational data indicate that changes in the climate system are continuing at a faster rate than reported in the IPCC 2007 report. The rate of change in land and sea surface temperature over the 21st century is expected to at least double that of the 20th century. The consequences of continued change necessitate a risk management approach to climate-related decision-making. Decisions should be based on assuming a global temperature increase of 3 to 4 degrees Celsius. Best case, 2 degrees Celsius. Worst case, 5 to 7 degrees Celsius by 2100. This necessitates including the potential for high-impact abrupt changes. In other words, we really need to do something about that, and we need to do it now. Now, one of the outcomes this report didn't discuss is ocean acidification. And this could have a devastating effect on many species of marine life and the ocean's food chain. Now, an article at Reuters titled Ocean Acidification Could Disrupt Marine Food Chain tells us that Ocean acidification caused by climate change is making it harder for creatures from clams to sea urchins to grow their shells, and the trend is likely to be felt most in polar regions. It goes on to say that a thinning of the protective cases of mussels, oysters, lobsters, and crabs is likely to disrupt marine food chains by making the creatures more vulnerable to predators, which could reduce human sources of seafood. It says that human emissions of greenhouse gases include carbon dioxide from burning fossil fuels, and some of that carbon dioxide ends up in the oceans where it dissolves to form acid. The ocean acidification makes it harder for creatures to extract calcium carbonate, vital to grow skeletons and shells, especially from chill waters in the Arctic Ocean and around Antarctica, according to a study in the journal Global Change Biology. It goes on to say, so a shift toward acidification in the ocean is likely to force animals to have smaller skeletons. And then a quote, we think that polar regions, and especially Antarctica, are likely to be the first places where animals reach these critical problems for making skeletons. And that comes from Professor Lloyd Peck of the British Antarctic Survey. And then the article goes on to basically say there is hope. That it says, given enough time and a slow enough rate of change, evolution may again help these animals survive in our acidified oceans. Basically saying that there is a chance that these animals can adapt. But this is making the assumption that evolution can't keep up with the changes that are going on in the ocean. And of course, evolution isn't an instant process. It takes millennia for things to adapt and evolve. And these adaptations happen with natural processes that go on in the Earth. What's going on in the Earth right now isn't necessarily a natural process because we are dumping carbon into the ocean much faster than would be the normal rate. So I guess it's good to be optimistic and think that maybe there's the possibility that these animals can adapt and evolve. And obviously that is a possibility. But it's my thinking that that isn't going to happen. And so kind of staying on the side of optimism, there's an article in Wired titled, Plankton May Hold Up Well to Ocean Acidification. So that sounds good, right? Plankton is basically the base of the food chain in the ocean. And what this article does is it begins by talking about how they did a study on chalk and how chalk decays, and how what chalk is composed of is kind of in a way similar to how the shells are made on some of these creatures in the ocean. So I'm going to pick it up probably about halfway through the article here, and it says, what does this information tell us? For starters, it explains the microscopic characteristics of chalk, but, more importantly, it helps us predict the effects of ocean acidification more accurately. Some marine plankton and invertebrates build shells from aragonite, a form of calcium carbonate which dissolves more easily than calcite, and these organisms will be the first to feel the effect of increasing ocean acidity. Calcite-secreting organisms which aren't as resistant as coccolithophores will be next. Near pH 7.8, coccolithophores and any other groups that stabilize calcite similarly will be in trouble as well. Projections vary with scenarios of future emissions, but most put the average ocean pH at 7.8 before the end of the century. Average pH has already decreased by about 0.1 units since pre-industrial times to roughly 8.1, a nearly 30% increase in acidity. With regional and seasonal variation, some areas will experience a pH of 7.8 or lower much sooner, most notably in the Southern Ocean. And go ahead and take out a globe, or even kind of look at a map of the Earth. I think you're going to notice that, probably about 70% of the ocean actually lies in the southern hemisphere. So what this is basically saying is almost antithetical to what the title of this article itself says. Plankton may hold up well to ocean acidification. No, they may just hold up a little bit longer. But it still is basically saying by the end of the century, the acidification of the ocean will make it so that plankton will likely not be able to survive. And if plankton can't survive, then pretty much the entire food chain falls apart in the ocean. The entire food chain basically falls apart in the world. That's pretty huge. I don't want to be a doomsayer, but we can probably adapt to a lot of things, but I don't know how we adapt to basically the disintegration of the entire food chain. So let's turn now to Dr. James Hansen. And you can go to the show's website and view the entire TED Talk containing the audio from the show's opening. Now, Hansen's been warning us of the proverbial iceberg in our path, or perhaps the melting iceberg, since 1981. In that year, while working at NASA, Hansen and several of his colleagues published an article in Science titled Climate Impact of Increasing Atmospheric Carbon Dioxide. And this is the first paragraph of that report. Atmospheric CO2 increased from 280 to 300 parts per million in 1880 to 335 to 340 parts per million in 1980, mainly due to burning of fossil fuels. Deforestation and changes in biosphere growth may also have contributed, but their net effect is probably limited in magnitude. The CO2 abundance is expected to reach 600 parts per million in the next century, even if growth of fossil fuel use is slow. And of course, 1880 is roughly the beginning of the Industrial Revolution when we really started to burn fossil fuels. And this paper provided 6 models containing multiple variables and scenarios, all of which basically posited that due to human action since the beginning of the Industrial Revolution, that CO2 parts per million will continue to increase, as will the ocean and surface temperature of the Earth, resulting in ice sheet melt, sea level rise, coastal flooding, extreme droughts, and the opening of the Northwest Passage in the Arctic Ocean during the summer months, among other things. Now, this was basically the first comprehensive research done concerning climate change, and Hansen himself stated that there were many unknowns. And I think that's why he created 6 models. But I think that if you look at his basic predicted outcomes, and reality on the ground right now, his modeling over 30 years ago was quite prescient. Think about that list of consequences I went through that were detailed in the Department of Defense report. That report came out exactly 30 years after Hansen's initial climate change research. So here I'm going to get a bit cynical, but please follow me for a minute. In 1981, we were warned about a problem that we were self-creating due to our burning of fossil fuels, a problem that has serious health, economic, and national security implications, but the warning was basically ignored, and it continues to be basically ignored. Meanwhile, right about that same time, Reagan has the solar panels removed from the White House, which Carter had installed, signaling a big screw you to the possibility of addressing the problem early on. But I don't just blame Reagan, because every president, Republican or Democrat since 1981, has been ineffectual concerning properly addressing global climate change, and I'll get more into why I think that is later in the show. Anyway, something else has happened around that time, the Iran-Iraq War. So what do? We supply Saddam Hussein with weapons and chemicals that he will use to create chemical weapons, which will be part of the reasoning as to why we need to attack his country 20 years later. Remember, beyond the WMDs that weren't there, we were also pointing out his use of chemical weapons on the Kurds in the north of Iraq, and the fact that he still has chemicals and will use them, possibly on America, if given the chance. Well, how do we know he had them? Because we had the frickin' receipt of sale to him. Now, I went down this road because I wanted to point out that we were quick to address a self-made problem when it came to going to war, a war that has cost countless lives, both military and civilian, and trillions of dollars. Yet we still refuse to properly attack another self-made problem, global climate change. Again, I'll get into why I think this hypocrisy exists later in the show, but spoiler alert, it's about money, more specifically, who makes it. So, in 1998, Hansen and some of his colleagues published another research report concerning climate change in the Journal of Geophysical Research titled Global Climate Change as Forecasted by Goddard Institute for Space Studies Three-Dimensional Model. It seems that this report piqued some interest in Washington, as he was asked to issue his findings to Congress by Senator Tim Wirth, a Democrat from Colorado, in June of that year. And in his testimony to Congress, Hansen basically stated 3 key things that he said he believed with a high degree of confidence. 1, the world was getting hotter on decadal timescales, meaning that each decade was going to become warmer than the next. 2, man-made emissions were largely the cause of the warming. 3, in his climate model, there was a tendency for an increase in frequency and the severity of heat waves and droughts with global warming. In his report, Hansen provided 3 models of possible outcomes due to climate change. These models took into account uncertainties over the prospects for government regulation and volcanic eruptions that can mask the effects of greenhouse emissions. Now, it was Hansen's belief that Model B was the most likely outcome, and as it turns out, he was basically right. Now, looking at his modeling predictions from 1988 to 2008, Model A overestimated radiative forcing by 50%, C underestimated it by 25%, and B overestimated it by 10%. Now, radiative forcing is essentially the difference between the amount of energy that enters into the atmosphere and the amount that is allowed to escape. As CO2 builds up in the atmosphere, less energy is allowed to escape, resulting in rising temperatures. I think that given all of the variables that need to be considered, and also not knowing what kind of feedback loops that might arise over the 20 years, being within 10% tells me that Dr. Hansen's research is credible, and that any estimates or predictions about where we should be heading over the next 25 to 50 years should be looked at. But, of course, his research was received with skepticism in 1988, with many people, most of them politicians, saying that further research needed to be done. And that was fine then. Climate science was relatively new, and scientific research should always be met with skepticism. After all, it isn't a religion. You can't just believe in it blindly. However, the naysayers are still saying 25 years later that they need more research and or proof. Even the Department of Defense report was calling for better modeling, while at the same time detailing the devastation that global climate change has already caused and will continue to cause. Well, the research is in, and the proof is in the rising ocean, the acidification of the ocean, the melting glaciers, the extreme weather patterns, the opening of shipping lanes in the Northwest Passage of the Arctic Ocean, and so on. And action needs to be taken now. We simply can't afford 25 more years of research before we decide to take action. Now, I'm not going to get bogged down in discussing Hansen's research any further, but I've included links to other reports or speeches he has given over the past 25 years. Now, check them out and decide for yourself whether we can continue to waffle on this issue. We should have taken action a quarter of a century ago. Hell, over 30 years ago. But more importantly, we need to start taking action immediately.
I'm beginning to think you are utterly insane. Why are we in costume? How did I get here? It's not my idea to hit the stratosphere. And I don't wanna do it. No, no, no. I don't wanna do it. No, no. So you jump first. You jump first. You jump first. I don't wanna do it. No, no, no. I don't wanna do it. No, no. So you jump first. You jump first. You jump first.
So before I get into why I think we stay entrenched in the extraction and use of fossil fuels, I want to quickly point out a few recent reports that support why I think there needs to be urgency in drafting policy that effectively addresses climate change. Policy that moves us away from subsidized fossil fuel extraction and toward ubiquitous use of green energy, specifically solar. A report issued in November 2012 by the Potsdam Institute for Climate Impact Research, titled Projected Sea Level Rise May Be Underestimated, reveals that sea level rise over the last decade is greater than IPCC projections, while global temperature increases have remained within its best estimates. And the IPCC is the Intergovernmental Panel on Climate Change. Now, this report tells us that the results confirm that global warming, which was predicted by scientists in the 1960s and 1970s as a consequence of increasing greenhouse concentrations, continues unabated at a rate of 0.16 degrees Celsius per decade and follows IPCC projections closely. Data of sea level rise provided a different picture, though. The oceans are rising 60% faster than the IPCC's latest best estimates, according to the new research. The researchers compared those estimates to the satellite data of the observed sea level rise. Satellites have a much better coverage of the globe than tide gauges and are able to measure much more accurately by using radar waves and a reflection from the sea surface, explains Annie Kazanavi from Lagos. While the IPCC projected sea level rise to be at a rate of 2 millimeters per year, satellite data recorded a rate of 3.2 millimeters per year. The increased rate of sea level rise is unlikely to be caused by a temporary episode of ice discharge from the ice sheets in Greenland or Antarctica or other internal variabilities in the climate system, according to the study, because it correlates very well with the increase in global temperature. So what are the implications here? Well, according to reports by the U.S. Geological Survey, as reported by World Watch Institute, approximately 1 billion people are threatened by sea level rise. That's about 1/7 of the population of our planet. Or to put it another way, 1 in 7 people alive today are threatened by sea level rise due to global climate change. To put that into perspective, 1/7 of the U.S. population is about 48.5 million people. You could add up the populations of the top 10 most populated cities in America and still have 25 million people left over. Now, this threat is imminent. Reports estimate that the sea level will rise by 2 to 3 feet by the end of the century. That's only about a lifetime away now. Do you have children? Grandchildren? This is their problem. This is the legacy we are leaving them. And even if we act now to curb emissions, we can't stop sea level rise from happening. It's already set in motion. However, if we work now to drastically curb emissions and put a plan in place to get the CO2 parts per million back to acceptable levels, we might just see the light at the end of the tunnel come the end of this century. Moreover, what we can do in the short term is plan for the catastrophes to come. Instead of looking to eliminate a program such as FEMA, we need to work to strengthen it, so we have comprehensive plans in place to react to the devastation that is sure to happen over the next century due to global climate change. Now, there is another problem that has been arising recently due to global climate change, and that is methane release from Arctic permafrost. An article found in The Guardian titled Arctic Permafrost Leaking Methane at Record Levels, Figures Show, reveals that methane emissions from the Arctic have risen by almost 1/3 in just 5 years, and that sharply rising temperatures are to blame. The article tells us, the discovery follows a string of reports from the region in recent years that previously frozen boggy soils are melting and releasing methane in greater quantities. Such Arctic soils currently lock away billions of tons of methane, a far more potent greenhouse gas than carbon dioxide, leading some scientists to describe melting permafrost as a ticking time bomb that could overwhelm efforts to tackle climate change. They fear the warming caused by increased methane emissions will itself release yet more methane and lock the region into a destructive cycle that forces temperatures to rise faster than predicted. Paul Palmer, a scientist at Edinburgh University who worked on the new study, says, high-latitude wetlands are currently only a small source of methane, but for these emissions to increase by a third in just 5 years is very significant. It shows that even a relatively small amount of warming can cause a large increase in the amount of methane emissions. Global warming is occurring twice as fast in the Arctic than anywhere else on Earth. Some regions have already warmed by 2.5 degrees Celsius, and temperatures there are projected to increase by more than 10 degrees Celsius by 2100 if carbon emissions continue to rise at current rates. Palmer said, this study does not show the Arctic has passed through a tipping point, but it should open people's eyes. It shows there is a positive feedback in that high temperatures bring higher emissions and faster warming. A new study follows repeated warnings that even modest levels of global warming could trigger huge increases in methane release from permafrost. Philippe Sieyès, it's a French name, I'm not sure if I'm pronouncing that right, a researcher with the Laboratory for Climate Sciences and Environment in Givry-sur-Yvette, France, again not sure if I pronounced that right, told a scientific meeting in Copenhagen last March that billions of tons could be released by just a 2 degrees Celsius average global rise. And then on the bottom of this article, it's got a part that says more on methane. And it says, while carbon dioxide gets most of the attention in the global warming debate, methane is pound for pound a more potent greenhouse gas, capable of trapping some 20 times more than CO2. Although methane is present in much lower quantities in the atmosphere, its potency makes it responsible for about 1/5 of man-made warming. Now the fear here is that methane emissions due to climate change will create a feedback loop, essentially increasing the rate of warming. Now as noted, methane is a more potent greenhouse gas than CO2. So again, we need to take action immediately in order to get the CO2 parts per million back to acceptable levels. It was reported in June 2012 that we are now approaching 400 parts per million, and estimates are that we will be at 600 parts per million by the end of the century. Acceptable levels are 350 parts per million and below. Now beyond the warming that will be caused by the continued rise in CO2 in the atmosphere, if we hit 600 parts per million, we will find the air hard to breathe. We are essentially slowly asphyxiating ourselves through this orgy of autoerotic carbon-based fuel extraction and burning. And I'm not even going to discuss the damage that the extraction of coal and oil and the like does to the environment in this podcast. That could be another show entirely. All I'm going to say is that we are allegedly the most intelligent species on this planet. Yet we are the only species that I know of that shits where they lay. Granted, it's a metaphorical shit, but as Shakespeare said, a rose by any other name is still a rose. Okay, so on to why I think we continue to metaphorically shit in our own beds. And as I said earlier, it's all about money, more specifically, who's making it. Now, I believe in the basic principles of capitalism and allowing supply and demand to shape markets and spur growth and innovation. However, I believe where energy is concerned, capitalism is holding us back. Worse, as I stated earlier, it's causing us to slowly asphyxiate ourselves. So what do I mean by that? Well, it seems to me quite obvious that we continue to value short-term profits over long-term environmental sustainability. But that's the nature of capitalism. Acquire maximum profit in the shortest period of time, regardless of externalities. Now, when the externality happens to be a competing business or entity in your market, that's fine. That's the nature of the beast. However, when the externality is the environment that we live in, this results in a huge problem, at least for me, and I'm quite honestly baffled why anyone would see it any other way. Fossil fuel extraction is one of the most lucrative business ventures in the world, so why would those involved in that business want to give it up? Look, when you have a cash cow, you don't send it to the slaughter. You continue to milk it dry. I have no doubt that those involved in the fossil fuel industry are well aware of the damage and destruction they are causing directly to the environment through extraction, as well as the long-term effects and implications of global climate change due to the burning of those fossil fuels. But they don't care. They only care about profit. They are being good capitalists. Moreover, the politicians who are supposed to be representing us, representing the interests of the people, don't care. They only care about the campaign contributions and other various perks that are made available to them by energy companies. And the worst part about this is that we are subsidizing our own demise. Depending on what factors you consider, the federal government provides $10 to $52 billion in subsidies to energy companies that extract, refine, and/or distribute fossil fuels. These same companies continually rake in record profits each fiscal quarter. So even if we look at the low end of that figure, $10 billion, let's put that into perspective of the other spending that we do. According to the 2012 fiscal year budget, $7.4 billion was spent for supplemental nutritional assistance to low-income families. So at the minimum, $2.6 billion less was spent for supplemental nutritional assistance to low-income families, otherwise known as welfare. But $10 to $52 billion worth of welfare to companies that make billions of dollars each quarter is okay. And we spent, in the fiscal year 2012, $6.5 billion for renewable and clean energy research and development. So $3.5 billion less than we are handing to the companies that are causing the destruction of our environment. $8 billion was spent in 2012, and then $53 billion are going to be spent overall to provide 80% of Americans with convenient passenger rail system. That's good. But if you put that into perspective, in 1 year we could hand $52 billion to energy companies, but it would take 6 years to try to put that money into building a high-speed rail system that can be available to 80% of people in this country. Now conversely, over 6 years, we're going to spend $556 billion on surface transportation infrastructure, otherwise known as roads and bridges. And that's really just another form of subsidy to the energy companies. And then in the fiscal year 2012, we spent about $100 billion in total for education. So if you take the high end of what we subsidize to energy companies, they get about half of what we actually pay for education. So what kind of profits do these companies earn that we are so generously subsidizing? Well, in 2011, BP made $26 billion, ExxonMobil made $41 billion, Shell made $31 billion, Chevron made $27 billion. Koch Industries, which is privately owned, was reported by Forbes as having $98 billion in revenues in 2011. Now that's revenues, not profit, but I have to assume that they are a pretty profitable company. And why is it that companies make such profits can still receive such lucrative subsidies? Something that is called welfare when common folk like you or I receive it. Well, because they can. Because they own the politicians. Because everything is about money, and money is everything. I believe I made the statement several times at various podcasts that our politicians chase our votes, but then follow the money. Our votes get them elected, but it takes a lot of money to win, and the bulk of the money for campaigns comes from corporate contributions. And, of course, these corporations are going to want something in return for their generous contributions. In the case of the fossil fuel industry, they want our politicians to maintain the status quo, that being keeping us dependent on fossil fuels, even if it means the destruction of the environment that we depend on to live. So here's what some of these companies contributed to campaigns in 2011 and 2012. And to be fair, the money has gone to Democrats and Republicans alike, although about 75% of it went to Republicans. Now Oxbow, which is owned by Bill Koch, who is the brother of David and Charles Koch of Koch Industries, Oxbow gave $4.2 million in contributions, Chevron gave $3.8 million in contributions, ExxonMobil gave $2.3 million in contributions, Koch Industries gave $2.23 million in contributions. And then in 2008, President Obama himself took in $884,000 in contributions from energy companies. And this makes me understand Obama's stance now on energy. In 2008, during the campaign, he was very vocal about trying to promote green energy, about trying to move us forward in that realm. And then, of course, in the last campaign, he was basically mute on it. Well, he was chasing our vote, but he's following the money. It seems to me that what we hand out in subsidies to these companies, they're handed right back to the politicians so that the politicians can be the proxy for the policies that the industry wants. We will never have the type of comprehensive and progressive energy policy that we need as long as this continues to happen. The reality is that the naked capitalist doesn't care about anything but increasing their capital. They stay so sharply focused on growing the pile of wealth in the vault that they fail to notice that the bank is burning all around them. Now, I've mentioned Koch Industries a few times. They are huge players in the coal industry. But interestingly enough, recently the Charles G. Koch Charitable Foundation was a leading funder for BEST, the Berkeley Earth Surface Temperature Study. This study was led by Richard Muller, who was a leading skeptic of global climate change. Well, after conducting his research, which was ultimately intended to debunk climate change, this is what Muller had to say in July of 2012. Call me a converted skeptic. 3 years ago I identified problems in previous climate studies that, in my mind, threw doubt on the very existence of global warming. Last year, following an intensive research effort involving a dozen scientists, I concluded that global warming was real and that the prior estimates of the rate of warming were correct. I'm now going a step further. Humans are almost entirely the cause. Moreover, Muller had this to report. Our results show that the average temperature of the Earth's land has risen by 2.5 degrees Fahrenheit over the past 250 years, including an increase in 1.5 degrees over the most recent 50 years. Moreover, it appears likely that essentially all of this increase results from the human emissions of greenhouse gases. These findings are stronger than those of the Intergovernmental Panel on Climate Change, IPCC, the United Nations group that defines a scientific and diplomatic consensus on global warming. I think this is possibly the most significant evidence I've ever seen that global climate change is happening, and that it is largely due to human activity, i.e., burning of fossil fuels. After all, this report comes from a converted skeptic who was basically funded by the fossil fuel industry to find evidence that would debunk global climate change. I don't think that we can or should debate the issue any longer. However, even with this evidence, the industry keeps moving forward, looking for further ways to squeeze a few more pennies out of the earth. We can't expect these companies to see the coming apocalypse when all they can see is dollar signs. Nor can we expect politicians to take the lead when they are only concerned about procuring campaign contributions that are necessary for their election campaigns. We need to take the lead, common citizens. We need to go on the offensive, bombarding our elected officials with our demands, and we need to do it in force. The show's website has a host of links that you can use to contact your representatives. Please use them to demand that climate change be moved to the top of their agenda.
A paper boat down a flooded street. While the water keeps rising, I feel at peace. The weight of my life lifted off my shoulders. If I finally die here, will bury me facing east. Fox got its hole, a bird's got its nest, but the son of man hath not where to lay his head. In case they find me dead, I won't be going to hell. No, the only hell I believe in is the one that we make ourselves. Fill the tub and keep.
So what do we know? We know the Earth is heating up, glaciers and ice sheets are melting, sea levels are rising, there is increasing acidification of the ocean, major storms are becoming more severe and occurring in areas where they never used to, droughts are becoming more frequent and more severe, and so on. And this is, for the most part, caused by human burning of fossil fuels. Even research funded by the Koch brothers came to this conclusion. So what are the solutions? Well, for one, the U.S. needs to become a world leader in tackling the issue head-on. We need to sign on to international agreements such as the Kyoto Protocol to show that we are serious and willing to take action. And you can go to the show's website for a link to details about Kyoto. If we take action, I believe the rest of the world will follow suit. However, there is a problem with developing nations such as China and India who feel that they should be allowed to go through the same growth processes that the developed nations of the Western world did. And that process involved a massive extraction and burning of fossil fuels. And I believe they have legitimate beef here. We can't ask them to curb emissions at the cost of carbon production and growth, any more than we are willing to ask that of ourselves. But if we do what I am about to propose, we can ensure that every person in the world can get clean, cheap energy, which means that all nations can develop quicker. President Obama says that he is only willing to address climate change to the extent that it won't hurt the economy, and that's fair enough. But I believe that we can address climate change in the manner that is needed to get us on the path back to 350 parts per million and also improve the economy. Now, my idea might not be what's best for the 1%, but I believe it would be a boon for the 99%. And to be clear, what I'm about to talk about isn't some groundbreaking proposal. It's just one that has been largely ignored, because those that currently control the world's energy supply also control the message, and they would like to continue to control how we get our planet cooking energy. So here it goes. Over the past decade or so, there has been a lot of talk about various alternative energies: wind, geothermal, hydroelectric, biofuels, methane capture from sewage and landfills, clean coal, nuclear, and so on. It's my thinking that we need to focus on one form of clean energy, solar. More so, we need to focus on developing ways to store solar energy. We need a to-the-moon-like project that we had in the 60s, except this one will be to develop batteries or some form of collection device that can store the abundance of energy that the sun delivers to us daily. The sun is the great energy plant in the sky, and it gives us clean energy for free, which of course scares the shit out of the capitalists. Now, we know how to collect the energy fairly well through solar panels and the like, although that can and should be improved, but we are sorely lacking the ability to properly store mass amounts of solar energy. So how much energy does the sun provide us daily? Well, according to Loretta Van Copenel, conservation chair at the San Antonio Sierra Club, the amount of solar energy that falls on the Earth's surface in 40 minutes equals the total annual energy consumption of all the world's people. Put differently, 27 years' worth of worldwide energy consumption equals 1 day's worth of solar energy hitting the Earth. All the energy in the Earth's reserves of coal, oil, and natural gas equals just 20 days of energy produced by the sun. I mean, think about that. 27 years' worth of worldwide energy hit the Earth each day. Clean energy. There it is. There is our energy solution. We don't have to drill for it, or fracture rock for it, or blow off mountaintops for it, or pollute our water table or oceans for it, or go to war for it. We just have to figure out how to store it for future use. And I think that if we really put our minds to it, we can do it. Moreover, I think that we must do it. It just doesn't make sense to me that we know this abundance of clean energy rains down on us daily, yet the solutions we constantly hear are to drill baby drill, or build a pipeline from Canada to the Gulf of Mexico, or ramp up fracking that has the potential to poison water tables and cause earthquakes, or blow off entire mountaintops and pollute the rivers around them, or poison our oceans with oil spills from shipwrecks or platform explosions, or create nuclear waste that we can't dispose of, or, well, I hope you get the picture. This is the future I imagine. Homes that have shingles or perhaps even window panes that act as solar collectors. Cars and planes that have a skin that acts as a solar collector. Solar power plants that can power large municipalities. High-speed rail powered by solar energy that connects major urban hubs. And batteries that can efficiently store large amounts of solar energy for future consumption. What's depressing to me is that this should be our present and not an imagined future. We should have started down this path 30 years ago, but we didn't. And that's the reality. So let's start down that path now, so we can live in that reality 30 years from now. But that will only become a reality if we develop efficient, high-capacity storage cells for solar energy, as well as develop more innovative ways to capture that energy. And I think such a project has to be spurred by government research and funding and then passed on to the private sector. And now this isn't that uncommon. Things such as our rail system, the telegraph, many medical advances, GPS, and even the internet, to just name a few, were initially either government research projects or research funded by federal money. Contrary to popular sentiment of many conservatives, government can do things and spur innovation. And in the case of global climate change and spur innovation that leads us out of the dark age of fossil fuel extraction and use and into the light of capturing and utilizing clean and abundant energy from the sun, it is my contention that it must. Now, what I propose is long-term thinking, although I hope that if we did launch such a project, that we could accomplish our goal of creating some kind of efficient solar capturing system within a decade. However, in the short term, James Hansen mentioned something in his TED speech that I believe could work to help us transition out of carbon-based fuels. And this is what Hansen had to say.
Now, the tragedy about climate change is that we can solve it with the simple, honest approach of a gradually rising carbon fee, collected from fossil fuel companies and distributed 100% electronically every month to all legal residents on a per capita basis, with the government not keeping one dime. Most people would get more in the monthly dividend than they pay in increased prices. This fee and dividend would stimulate the economy and innovations, creating millions of jobs. It is the principal requirement for moving us rapidly to a clean energy future. Several top economists are co-authors on this proposition. Jim DePeso of Republicans for Environmental Protection describes it thusly: transparent, market-based, does not enlarge government, leaves energy decisions to individual choices, sounds like a conservative climate plan.
This is a plan devised by economists that considers the energy consumer, the economy, the environment, promotes innovation, and is deemed acceptable by a leading conservative environmentalist. But will we even consider implementing it? Not likely. At least not as long as fossil fuel burning energy companies continue to dictate our energy policy. So again, it is up to us, the voting public, the silent majority, to stop being silent and start demanding that our government adapts an energy policy that is truly progressive, an energy policy for the 21st century and beyond, rather than maintaining the status quo and continue a policy that keeps us locked in the 19th century. This will benefit conservative and Democrat alike. Now, I had intended to include a section in this podcast concerning the media's lack of properly addressing the issue of climate change, but this episode is already run long, so I'm going to have to leave that material on the cutting room floor. However, I have included links to a great article written by Wen Stevenson, along with an interview from PRI's Here and Now featuring Stevenson talking about that article. Stevenson is a former Boston Globe editor and offers some keen insight into what role the media should be playing concerning this issue. So please go to the links page on the show's website and check those out.
Damn, if I hear another amateur near a mic, I might throw a samurai spear. My sanity clear. You crying with your ass out in Vanity Fair. If your family was there, your favorite Auntie Claire would stare. Disillusioned, completely unaware of your deviant movement. homeless. You live a double life, two-sided razor edge of a Swiss blade knife. The bitch made tight. I recognize real, something just ain't right. Off top, belly flop. The intuition of a mall cop. Adolescent prepubescent until your balls drop. All talk, blew my rocks off. Barely in junior high. You told tall tales and carried the newest lie. Who am I? A spiritual being, not caught up in material things and clear thinking. Keep me.
Where's my goddamn money, you bum?
Man, nothing is fucked here.
Thing is fucked. The goddamn plane has crashed into the mountain.
Well, that's going to conclude this episode of Left, Right, in the Middle. As I stated in the opening, I don't expect that this show will convince anyone to believe global climate change is happening who doesn't already believe it, as I believe their denial is based more on ideology than on actual science or the facts on the ground. What I do hope is that those who do believe global climate change is happening have a greater understanding of the urgency of this issue and are willing to take action. We have to let our representatives know that this issue is more important to us than the economy or the deficit or gun control or immigration or any other issue that comes to the forefront. Why? Because if we don't properly address global climate change, none of these issues will really matter in our grandchildren's lifetime. Moreover, I believe that we can address it, provide jobs, and improve the economy. We've been warned for 30 years about the dangers and ramifications of global climate change by James Hansen and have failed to take proper action. A recent Koch brother-funded study confirmed that global climate change is real and created by human emissions. The Department of Defense believes that global climate change is the most serious threat to national security we are facing today, more so than terrorism. There are dire implications to life as we know it on this planet if we don't act now. We are facing rising sea levels, increased storm frequency and intensity, increased drought and famine, mass extinction and the possible breakdown of the food chain itself, and so on. Before I sign off, I'd like to read something that Albert Einstein wrote in 1938 that I think still applies to modern times. It's titled, Message for Posterity. Our time is rich in inventive minds, the inventions of which could facilitate our lives considerably. We are crossing the sea by power, and utilize power also in order to relieve humanity from all tiring muscular work. We have learned to fly, and we are able to send messages and news without any difficulty over the entire world through electric waves. However, the production and distribution of commodities is entirely unorganized, so that everybody must live in fear of being eliminated from the economic cycle, in this way suffering for the want of everything. Furthermore, people living in different countries kill each other at irregular time intervals, so that also for this reason, anyone who thinks about the future must live in fear and terror. This is due to the fact that the intelligence and the character of the masses are incomparably lower than the intelligence and character of the few who produce something valuable for the community. I trust that posterity will read these statements with a feeling of proud and justified superiority. Now, Einstein also said that the definition of insanity is doing the same thing over and over and expecting different results. Let's prove to future generations that we weren't insane. We were just perhaps a little drunk on fossil fuels for a while. Well, please join me in 2 weeks for another episode of Left, Right, in the Middle. I have no topic planned at this time. Until then, please check out the links at the show's website, lrtmpodcast.com, and join the conversation on the Facebook page. I welcome your comments concerning this show or any other political topic. And please, everyone, contact your representatives and tell them how important this issue is to you. So until next time, thanks for listening.
To stop it, already went too far. Can feel the dragons breathing, can hear the monsters roar. We will strike the seas now, even if we reach the end.